Okay, so it's already 5:11. The usual start time of this class is 5, but as I see that no one is joining, so I am going to start discussing the questions given in the assignments, and maybe if someone need to check the live session, they can go through the videos which will be uploaded in the YouTube. So this is the week 9 of our live interacting session, and unfortunately no one is joining the class. So as per instruction, again I have to introduce myself. So I am Sripan Mandal, working at IIT as a research scholar, PMRF research scholar, and this uh, conducting these live sessions is a part of my deliverables towards my PMRF scheme. So till now in this computational physics course, we started with some basic programming, short programmings, where we tried with some random number generators, and then we uh, go to the Ising models. We calculated some thermodynamic properties from that Ising models in 3D, three dimension, and then what we did that we calculated the integration by different methods, as well as we calculated the differential ordinary differential equation as well as the partial differential equations, and then partial differential equation. And now what we have is essentially again this is a differential equation which is related to quantum mechanics. So whenever we study quantum mechanics, one thing comes into the picture is the Schrodinger equation. So what does it tell basically? So Schrodinger equation is like, say I am going to write something here. So minus h cot square by 2m d2 psi dx square plus v psi equals to e psi, right? So depending upon the potential and the energy of the particle, the wave function will have different forms. If energy will be higher than the potential, then it will be like a scattering state, and if energy is less than v, that means that will be a bound state. Okay, so from solving this equation, if we know the form of potential as well as the energy, so we can calculate the energy, as well as then we have to calculate the psi for different energy states, right? So let us move on to the first question. So it is asking that which of the following are incorrect for a 1D quantum mechanical simple harmonic oscillator, the potential. So if you remember, the simple harmonic oscillator will have a potential of the form of V equals to half k x square, right? So this is a well-known potential whenever we are studying classical mechanics, but when it is we move on to the quantum mechanical part, then this k is essentially written as m omega square, where m is the mass of the particle, omega is the frequency related to the motion of the particle, and x is the coordinate. So v equals to half omega m omega square x square. So as you see that this is a function of x, right? So since it is depending upon the x square, that means it is depending upon a power of x which is even, right? So the power is 2, so this is even. So we can say that v minus x, right? So if we take minus sign with x, then it will be equals to vx. So that means it is symmetric. So it is asking for the incorrect statements. So the antisymmetric is a incorrect statement for this potential. Also, the potential can have both positive and negative values irrespective of the curvature of the potential energy surface. Now as you see that this potential cannot have any negative value. Why? Because you have a x, right? So let's say you have this type of it will have something this type of a, sorry, this will be like this. So you see whether the x is negative, here the x is negative, and in this area this will be x is positive, right? But for both the Vx will have a positive value. So the another incorrect statement is that the potential can have both positive and negative values irrespective of the curvature of the potential surface, because this potential cannot have any negative values. It will always have some positive values and it will be symmetric in nature. So let's move on to the next question. So now the question is, in the bracketing or bisection method that is used to determine the eigenvalues, the difference between the maxima and minima of the energy is. So how we are going to calculate the eigenvalues? If you have seen the lectures given by the faculties, you see that they are using a bisection method to find out the energy. So basically you have this kind of a potential, right? So this is my drawing is not that good, so this is like a half kx square plot which we are using for the 1T harmonic oscillator. Now let's say it will have a energy of E, right? So what it will do is, this is a straight line. So what it will do, that it will start from a particular value, let's say x equals to 0, at which it will have a value of energy, and at let's say x equals to x max, that will be assigned during the programming. So it will calculate the E max and E min at those 2 points, and then what it will do, that it will bisect this total region between x equals to 0 to x max, right? How it is going to do? It will calculate the number of nodes in between them, and it will match the estimated number of nodes to the theoretically predicted or theoretically known nodes. So if it is higher than the nodes we required for that particular value, then it will diminish the upper limit. So in this way, so let's say if the energy which we are getting is higher than the energy which we are going to estimating, so then what will happen, this, just a second. Hi Shomitra, how are you?
Fine.
Yeah, okay. So is it helpful whatever I sent you? Study?
Yes, 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 it was.
Okay. So I just started by myself and I just having some discussion with myself only till now. So the first question was about the simple harmonic oscillator potential. So this is a just easy thing, right? Half kx square. So it will be which are the incorrect. So one is the incorrect thing is antisymmetric, and the potential cannot have the negative value because this is depending upon the x square. So these are the two options which are correct for this question. So the second question, you see, can you tell me which will be the correct answer for this question? That it is asking for that in the bracketing or bisection method that is used to determine the eigenvalues. Okay, so the difference between the maxima and minima of the energy. So there are some options which are going to correct for this question. Can you tell me? There are 4 things here. One is the maximum in the first iteration, and then decreases as the number of iteration increases as the number of iteration increases, and independent of number of iterations. So which ones are the correct for this question? Hello.
I'm not sure, sir, for this question.
Okay. So basically, bisection method is used for finding the eigenvalue. So it is initially we are giving two initial guesses for E mean and E max, and then what we are going to do is we are going to compare between our estimated the energy which we are going to estimate by knowing that how much or how many nodes we are going to expect for that particular energy level. And if we see that for our guess that maxima and minima, if we are finding that number of nodes is higher than the expected node, then we tell that okay, we have to diminish our upper level. Let's say we are firstly initially we are taking x equals to x max here, and then the number of node, if that is higher than the expected node, then we will diminish the minimum level to certain extent. And if the number of node is lower than the expected nodes, then we are going to diminish the level from lower energy. So in this way, the region where the energy is suspected to have its value, that will be shrink, and at certain points after some iteration we are going to find the exact eigenvalue. If not exact, then that will be a approximate value of the eigen state. Okay, so this is basically used for root estimation for the algebraic equations also. So this is exactly usually the same thing, or usually the same algorithm which we used for those kind of thing, and here we are going to use the same thing for calculating the eigenvalues. Okay, so
Yes, sir.
initially this will be the maximum in the first iteration, which will be our initial guess, and then it will decrease and it will move on to be the zero between this difference. So the difference between maxima and minima will essentially be zero when we reach the answer for our suspected energy eigenvalue. So these two things will be correct for this question. Now if we have the third question, this is just a basic question, you can answer it, right? So which of the
Yes.
yeah, so tell me.
Wave function and its first derivative should be continuous.
Yeah, correct. So this don't need any discussion, I think. Okay, so let's move on to the next question. So here they are saying that you have a potential of the form of bx to the power 4 minus cx to the power cx square. So this will have a value of, and if we write with the values of b and c, so you have x square minus 6, sorry, this is x to the power 4 minus 6x square. So this is given the potential. So the question is asking for number of maxima this potential will have. So how to find it? So basically you don't need a Numerov algorithm for this particular thing. This is simply a basic thing. So the first thing what we can do is to calculate the del v del x, the first derivative of v with respect to x, and we have to equate to it to be 0. So this will give us the information about extrema, but we cannot differentiate between minima and maxima by this. So this will conclude or include, sorry, this will include maxima as well as minima. And then if we need to find out the maxima, what we need to do, we have to take the second derivative, right, del 2v dx2, and for maxima it will have this to be less than 0. Okay, so what I did here is this page visible correctly, or I have to somehow?
No, it is visible.
Okay,
You have just calculated, plotted and calculated the maximum minimum of this function.
yes. So yeah, so see, for x equals to 0, it will be less than 0, right? So x equals to 0 will be a maximum point for this potential, and plus minus root c by 2b, those are the minima points for this potential. So what I did initially is I have plotted this. This might be an approximate plot, and if we go beyond this beyond these points, it will be like this points. So potential will keep increasing beyond this minus root c by b plus root c by b. So using some intuition, we can think of also the nature of the wave function. So basically, let's say if we think of a physical nature picture, that the psi, the probability density, actually gives us the probability of occurrence or probability of the particle to have at that particular position. So for equilibrium picture, what happens, a particle will try to stay at those points where the potential will have its minimum, because that is the stable state for that particle. So let's say if this is the configuration the potential have, so you see at x equals to 0 it will have a minima at this region, and there so sorry, this will be a maxima. So the probability of the particle to be found there will be less, so that will be essentially equals to 0, or if not 0, that will be a minima for that will be a minimum value for the probability. Also, if we have the potential minimum, so that means those are the stable areas, so there is a high chance of the particles to be found at those points. So there the wave function, that means the probability density, will be higher. So this is higher, right? So this is the potential and its corresponding wave function. So the first question is, how many maxima does the above potential have? So that will have the answer of 1. Okay, and
Yes.
yeah. So before moving on to the next question, the we have another question in the form of the nature of wave function. That is the last question. So what I am telling right now, so which of the following statements are not true about the probability density of a particle in its ground state in the above mentioned potential? So we already have the story depicted here. So what happens is, so it will have a minima at x equals to 0. That is one thing. And the second thing is, beyond this picture or beyond these points, what will happen? So potential is going to increase. So if potential is going to increase, and essentially if it is moving towards the infinity, then we don't have we have the wave functions which will be exponentially decaying as the x, that position is increasing, right? So if we move on to this, so which are not true, so the question is asking for not true. So which one are the correct answer? So let's say it will have a minima at x equals to 0. That is true. The second thing is the potential is essentially a symmetric potential, and we are considering about the ground state. So at the ground state it will be symmetric one also, and then is same for all values of x and is 0. So this is not the same, this is not the correct answer. So sorry, this is not correct, and as per question this will be our answer. Okay, since this is incorrect. Also decays exponentially to 0 at large values of x. That is also can be found by intuition, if not calculated exactly by solving the Schrodinger equation. Okay, so now let us move on to the second question, where we need to calculate the ground state energy using the Numerov algorithm. So it is asking for the ground state energy correct up to 2 places after decimal. So let's move on to the algorithm part. So okay, so I think it's better to show it in the directory, so just give me a few minutes. uh, is this window is visible to you?
Yes.
Yeah. So here I have written a program which is almost similar to the program written by the, I think, Dr. Prasenjit Ghosh. So what I did is, so essentially I am print the maximum value for x, which will be used as x max, and I have given this value to be 10, the typical value. Okay. So and then I have also given the number of grid points. I think it will be given as 1000. Okay. So then I am assigning the size of those arrays, let's say x, y, p, v potential and f. So we will found which of the array is associated with which quantities. So then the x max and mesh, so you have number of grid points and the maximum value for x, and the minimum value will be assigned to be 0. So you have total area covered by x in the x axis and number of grid points. So you can find the resolution for a particular grid, which will be given by dx. And then we have assigned a ddx to a variable. It is just a rename of this quantity, that dx square by 12. So if we follow the lectures carefully, then we can find out that why we need to calculate this dx square by 12. So that is some tedious calculation which can be found from the lectures. So I'm not going to depict all those things. So what then I do is we are calculating loop. We are starting a loop, and then we are saying that at each of the mesh points we are going to calculate the potential. So the potential will have a form of bx to the power 4 minus cx to the power cx square. So then p is 1, so this is essentially x to the power 4 minus c 6x square. So that is essentially what I have written in this line. Okay. So then I am going to print I'm going to give the output file name, and then we are going to open that file, and then I am going to open a loop which will search for number of nodes, how many nodes we are getting for our bisection method. Okay, at each iteration. So initially what it is doing, that it is asking for number of nodes. So basically we have to give the expected number of nodes for the particular energy state which we are estimating. So the question is asking for the ground state. So at the ground state we all know that it will not have any nodes. So the number of node at that particular state, which is ground state, will be 0. So since we are calculating ground state, then we will tell that okay, so in this step I am going to state that the number of node will be 0. So if node is less than 0, then we don't have anything to print or don't have anything to store in the file, the output file, because node cannot be less than 0. It will have the less value, the minimum value to be 0, which will be the value in the ground state. So then what I am doing, that we have a v potential array. Okay, so it will have many values depending upon the value of x. So it will have some maximum value as well as some minimum value. So these are the two things which are going to calculate your minimum as well as maximum value. Okay, so now it is asking for the trial energy. So we have to assign a value for trial energy at the beginning of our iteration. So if we are not we don't have any confirmation, or we don't have much intuition that how much trial energy we are going to get, then what I am going to do, that I safely say that okay, I am going to assign 0, and as soon as I am going to assign 0, then it will move on to this part, that if E is taken to be 0, then it is using the bisection method to update the value of energy at each iteration step. And how it is going to update? So basically you have a maximum value of energy and you have a minimum value of energy. So it will shrink the volume or shrink the area between those minima and maxima as the iteration is progressing by the bisection method. So what it is doing, initially E has an initial guess of 0 as the trial energy, and then it is updating the value of E as half of minimum plus maximum energy. So that will give you a energy estimation just just at the middle of the total area covered by the minimum and maximum. So then it is asking for that okay, so we are going to iterate this thing 1000 times. Okay, so after that it is starting the iteration loop. What it is going to do is it is asking for a loop which will be start from 1 and it will go to the number of iteration. Okay, so what it is doing, that there is a function which will have the first element to be ddx12, which is assigned or which is defined before. That ddx12 is nothing but dx square by 12. Okay, so it is dx square by 12 into 2 into v potential minus E. So this is the first element of the array assigned by f or defined by f. Then what I am going to do, then I am going to do the assignment of other elements also in the similar fashion, and then I am telling that okay, if the value of f at a particular point is going to be 0, then I am going to assign a value, a very less value, where fi is going to assign a value to be 10 to the power minus 20. So this is similar to 0 but not exactly 0. So this has to be done to make the numerical iteration to be a stable one. So then what I am going to do, that I am going to do for I am going to search for those points where the sign of this factor f is changing, and then I am going to say that okay, those points are the nodal points, and this way I will find the number of nodes in that particular regime. Okay, so you see that this line is very much essential for this bisection method. So what it is telling, that if fi, so you have an array of values of f that will have which will be calculated in this way, and then also I am assigning the value of fi to be 10 to the minus 20 if somehow at certain point f will be 0. So now you have the array fixed, and what we are telling, that okay, you have a first element, you have second element, and then you have third element. So I am going to use that if the fi and fi minus I both will have same value, then that is not a nodal point. But if they will have different signs, maybe someone is positive, the other thing is negative, so in that case I am going to tell that okay, that particular point will be a node. And then it is asking that okay, so we have total number of mesh, and if this number of nodes is much higher than mesh minus 2, then we will tell that okay, the node is pretty much at a higher point which we are not going to consider. Okay, so and we will deallocate our arrays. So then what I am going to do, that f is 1 minus f and then y is 0, then what I am doing here is h node, which is equals to nodes by 2. So we have total number of nodes to be equals to h node, sorry, twice h node. Okay, so if twice h nodes is equals to nodes, okay, so then what I am taking that okay, y naught will have a value 1, and then m is some calculation is here which can be find out from the lecture, and then we are going to assign the value of y at 0 and 1 element of the y array, and then what we are trying to do here is we are finding the number of crosses it will made, and then that number of crosses will be compared with the total nodes which we are expecting. Okay, so you see that you have started another loop which will be covered all the meshes, and then from there yi is again asking for change of sign. So if there is some change of sign, we are just adding that part, or that that part to be n cross. So initially n cross will have a value 0, and then we are having a logic that okay, if yi will have some other values than yi plus 1, then I will say that there will be a cross. Cross means it is going upward and then it is going downward. So there will be a point in which y will change its sign. Okay, so we are going to calculate the total number of, sorry, the total n cross. Okay, after the calculation happens, what I am going to do is I will calculate, or I will assign a logic that if n cross is greater than h nodes, n cross is the estimated value of those points where change of sign is happening. H node is the number of nodes which we are expecting by theoretical estimation. So if n cross is greater than h node, that means estimated points where the change of sign is happening, if it is greater than number of nodes, then EUP, that will be E. So what is that? That you have initially a EUP defined, the maximum value of potential, and that maximum value of potential is now updated to be the energy. Okay, so the total area is shrink for the upper level, else what it is doing, that ELW is going to be E. So this is shrinking from both sides. So after that what will happen, that now you have EUP and ELW, this will have some updated values, not the exact one which you have taken as initial parameters. So after that we are calculating again the value of energy with this updated value of EUP and ELW, and then how much time or how much duration this the bisection method will continue to happen is depending upon a parameter which is given by EUP minus ELW, that means the difference between maxima and minima. So as soon as it is minimum or it is less than the 10 to the power minus 10, then we are going to say that okay, so the difference is pretty much less. So we have already moved or estimated the ground state energy, so that will be printed as E. Okay, so and if, and then I am telling that okay, So if that this is less than 10 to the power minus 10, then I will exit this iterate loop. So the other things which we have at the later part of the code is not necessary for this particular problem. So we have to understand up to this point. So Mitra,
Yes.
is it okay?
Yes. Yes.
Okay. So okay, just a minute. I have to run the code once because that will give us some idea. So my code name is u1.f. So I'm going to tell that okay, report run u1.f /out. So it is a scheme part. Let's say this is 10 number of grid points. Let's say this is anything. So it will be 0 because we are asking for the ground state energy. So the trial energy, it will be given to be 0 because then it will ask the code to find out the energy by bisection method. So you see it needs total 47 number of iterations and the ground state energy is minus 6.642. okay, so how do I going to stop this program? So I have to type -1 and it will be exited. So the answer is minus 6.64272. And if we go to the question, just a second. Yeah, so if we go to the question here, so this is the correct answer. Okay, minus 6.64. okay, so this is correct answer. Okay, Shomitra, any issue?
No, sir.
Okay, so this is all about week 9. okay, so I am going to stop here and just a second, Shomitra, you can stay here. I'm going to ask you one thing.